Dear fellow members, colleagues and friends, thank you for joining the virtual lecture, Smarter Automation, Achieving Modular Smart Robotics and Europe-China Collaboration, brought to you by Institution of Mechanical Engineers, Hong Kong branch. I'm Wing Hei Sang, member, and I will moderate the webinar this evening in Hong Kong and noon in the UK. Although you are muted over the webinar, if you have any question to the speaker, please feel free to raise during the course of the webinar with typing it in the question and answer box. We will read the questions for the speaker to answer as many as we possibly can. Robotics. It's a hot topic in the mechanical engineering community, and our fellow colleagues in the UK have conveyed numerous talks about it. As far as Hong Kong branch is concerned, one was already organized in October 2019, and today we are contributing one more with modular robotics, which is a result of the collaboration in research and development between Hong Kong and the UK, as well as supply chains in China and European countries. Such experience of intercontinental collaboration on robotics, I believe, is novel to the IMechE community. And hence, I'm delighted to have the leaders in the field, Mr. Jonathan Chung from Innovo Robotics, to enlighten us about it. Well, Jonathan, your airtime is on.
Thank you very much, and thank you everyone for tuning in. And the Institute of Mechanical Engineers, thank you very much for giving me the opportunity to speak to everyone here and everyone's good selves. Yes, so my name is Jonathan Chung. I am co-founder, co-CEO of Innovo Robotics, and what we do is we do smarter automation, as the title suggests. But before we kind of go into the details of Innovo, I'd like to share a little bit of my professional background and where it all began for me, to give you a little bit of a perspective really on the Innovo journey and how we got to where we are now, and so some of the exciting projects that professionally I've been involved with. So to begin with, my professional background is as a mechanical engineer. I had my MEng in the UK, and I started my my career in robotics in the UK for a commercial but defence organisation called Kinetic. And so right from my early career days, I've heavily been involved with automation systems, robotics, robot arms, manipulators, and remote control vehicles. So here you see some examples of some robotic and remote vehicles. That you see on the bottom right is a remotely operated JCB digger for unexploded bombs, effectively. And the image on the right, on the top right, is a smaller bomb disposal research vehicle developed for the company in Kinetic, which is a UK-based defence company. And so that's really where professionally where my my career started, and moving on from robotics in bomb disposal. I spent a number of years working in transmissions, particularly in hybrid electric transmissions for tracked vehicles. So here you see on the right, it's a circa 30-ton military vehicle, tracked vehicle, and I was involved in the development of the electric transmission of this for a number of years as well. In my early days prior to developing Innovo, so this was prior in my prior life, and then moving a little bit further on in my professional world. I, I did a number of projects for the Home Office, for the Defence and the National Security in the UK, where I developed a very novel scene management barrier. Is a police barrier, which is a foldable trailer, which can act as a police movable shield, and the video you see here is in the UK. It's actually in Glasgow, where a helicopter unfortunately landed on crash landed on top of a vehicle. Sorry, on top of on top of a building, and as you can see, there's a perimeter of police barriers to protect the site, to keep privacy in that environment. And I'm very proud to have created a system which is being used so heavily and publicly in the security industry. So and then moving on into some later years within the in the robotics industry. One of my roles was as an engineering consultant for developing the UK next generation bomb disposal vehicle. This is the vehicle which is currently being used in the UK by the UK police, and it is heavily used to protect lives, to diffuse of unwanted explosive ordnance effectively. So the kind of defense systems that I've been involved with and very proud to be involved with are in the defense environment, and they actively save lives. So it was in this company that's actually the seedling of the idea of where Innovo would be born. Um, this was the company in 2009 that I met my co-founder, Henry Wood, and we worked together very successfully in this company to deliver this very advanced, very state-of-the-art military vehicle to very exacting standards. And it is where we first worked together and first started solving real problems together. And myself and my co-founder Henry, we embarked on some future projects together as consultants. So this very interesting project is actually a ground vehicle, and is a project that is was effectively for the Ministry of Defence, but the aim was to create a fundamentally more explosive proof vehicle. So a big problem within the military is military vehicles have to withstand a lot of explosions, abuse, and so what we did is we created a novel system, actually a novel suspension system, which would be fundamentally more robust from explosions than a conventional system. So this is a very exciting project, and I'm playing a very short video now where this vehicle is being tested in a military site in the UK, and the test environment was very interesting. We were were required to progressively apply more and more explosions or explosives to it, to try to test and validate the increase in performance to the novel suspension system. So this was a project funded by the Ministry of Defence as an R&D project, and was very rewarding. So after this project, we actually patented this novel suspension system, and we have maintained that patent. So so that's a very brief background, really, in terms of our journey on so far, or before the start of Innovo. But then Innovo was born with myself and Henry Wood, my co-founder, and with an image of him displayed there. And we decided that what we needed to do, or what we wanted to do, is bring our level of expertise solving very novel, high-end problems, our engineering background, to solve a problem which was much more widely seen in an industrial problem, as opposed to purely within security or military, where we felt that the market is quite contained or quite small in comparison. So what we did in 2016 is we started a new company called Innova Robotics, and this is where our journey started. So I mentioned briefly about the market that Innova is solving, and what we realized when we looked at the manufacturing market is it's incredibly manual. Every product that we make or is made, at least somewhere down the line, there is somebody putting it together. So whether it be packaging, whether it be assembly, whether it be piecing, loading CNC machines, or loading injection molding machines with loading the hopper, or somewhere along the process there are lots and lots of people where there is a lot of inefficiency. So globally, what we know is that manufacturing as an industry probably accounts for 2 billion people, and it is the greatest problem within manufacturing is this huge dependency on labor. And so what we are aiming to solve the problem of is to create an automation system which is smarter, which is more flexible, more adaptive, and is affordable to help lots of different businesses to be able to automate quicker and smarter. So that is really where we pivoted our journey and took our step into Innova Robotics. So Innova Robotics was founded in 2016 in the UK and in Hong Kong. So we took the very interesting step to start the company in two places, as which is quite unconventional, and we did it for a number of reasons. Firstly, we're quite ambitious, and so we wanted to maximize our opportunity in developing a company by looking at the best places that would give us the um, traction, the market opportunity, the supply chain management, and also the talent to be able to build our business. So we decided that what we would do, because we have worked extensively together, we were able to manage an engineering team very well. We have deep technical knowledge. So as I've said, my background is in mechanical engineering and product design and development manufacturing, and Henry's background is in electronics and software. And so our skill sets complement each other very, very well. So we looked at the different regions and markets to evaluate where the pros and cons would be if we were to start a business, where in the world would be the most sensible place, and we settled upon UK and Hong Kong, and our initial plans have been to use Hong Kong as an excellent base to be able to be very, very close to our supply chain in South China, to be able to work very closely with our manufacturers, our manufacturing partners, and then use our um, our outlets in the UK to be able um, to access a market which is suffering a lot of pain within manufacturing, and suffering a lot of pain in terms of the high labor rates that you see in the West, compared to in China and the South Asia region. So those were the main reasons for taking on this unique setup. So now I'm just going to jump out into a short video to really give a different a starting flavor to what Innovo is about. So I hope this The real goal of Innovo Robotics is to make democratized robotics, is what we call it. And so what we're trying to do is to give small to medium businesses of many, many different verticals the ability to automate and industrialize their everyday processes. So traditionally, a lot of big companies have been able to use robots and industrial automation, but those small businesses have been unable to really benefit from it. So what we want to do is create really easy to use, flexible tools which will help them to automate their everyday activities in their businesses. Good. Okay. Hopefully you can all hear me again. So just to talk a little bit about operations and how that really would work. So the UK and Hong Kong are separated by between 7 and 8 hours, depending on the time of year. And as I mentioned, the main reasons are listed on the right, and I'll go down one by one to briefly mention the reasons, obviously. So the supply chain in the East, affordable, low-cost manufacturing, being very, very close to our manufacturers help us to really manage the quality of our products, and to be able to also somewhat support our suppliers, our subcontractors, to get them to bring us exacting qualities of our products and exacting quality. So the market is the next area. So for our market is really aimed at small to medium businesses where there is a high labor rate, but there is an obvious need to increase automation. So that traditionally has meant that our market has been in high labor rate countries, the Western Europe, US, and also some of the Asian countries such as Japan and Korea. And those are our real countries where we're targeting first. But we've also had some very interesting traction and customers within Hong Kong, Singapore, and some other emerging Asian countries as well. Um, from a talent point of view, I will talk a little bit about talent and how our team is structured a little bit later. But our talent is mixed in both UK and Hong Kong, and we're very proud of our talent. Investment investment has been stronger for us in the West actually. So our company is backed from the UK through a venture capitalist fund. So those are all the main elements, the constituent parts that make Innovo. So now I'd like to sort of delve into a little bit of technical. Obviously, this is an IMechE talk, and all our members are mechanical engineers. So I'd like to delve a little bit more into the mechanical bits and pieces. And one area which is of real interest within the robotics part is the structural element. It robotics or manipulators are a quite specific type of structural problem. Effectively, we're always talking about cantilevers. These are cantilevered beams, and so our structures are always needing to be optimized for strength and stiffness. So the main reason, for obvious reasons, are that the more weight that you have out hanging in the cantilever, then the stronger your motors need to be further down the arm. So mass optimization is always a very important factor in robotics. So the lighter and stiffer that you can make a structure, the easier and the lighter and the less amount of power you'll use, and also the acceleration and deceleration times will also be increased, and your stopping distances will also be decreased. So there's always a real drive to increase the stiffness, reduce the weight, and so carbon fibers are always a preferred material. And so what we do here in Hong Kong, we have lots of different structural parts, but I've just focused a little bit more onto the carbon fiber arm section, and talk a little bit about that. So this is one of the carbon sections that we have, and it's the image on the right. We've specified our own layup, so our specific layup that I won't go into a huge amount of detail in, but this arm section is part of the final end portion of the robot arm, and where the mass is very critical, and the stiffness is also very critical. So what we've done is we've optimized the stiffness of this section to be able to withstand a lot of bending as well as torsional stiffness as well, and also to minimize the weight of this section. So we've spent a lot of time optimizing the layup in FE. We've also validated those the design by making samples, and what you see here in the middle image or photo is the carbon section pre-painted, doing having a stiffness test, which is just a dead weight with a dial gauge on it. So we work very closely with actually bike frame manufacturers in China who who specialize in making very rigid bike frames to give us the level of quality that we need, and we validate that products and quality, and 100% test it as well. So as a very brief example, on the bottom right, we have some machine parts. It's lots of different machine parts of and also some castings. So we have our casting suppliers, our CNC, our lathe suppliers, and lots of different manufacturing methods that we use within the product. So those are the piece parts. There's also within our team, within Innova, we have a number of patents. Um, we obviously have a modular robotic system, which I'll demonstrate in a little while. But what we have is a number of different mechanical physical patents. The first patent that we have is within our coupling mechanism. So we've created a modular system where we um, we are unwilling to compromise on the stiffness, the rigidity, and the repeatability that is required within an industrial automation system. So this level of performance is not available within any commercially available coupling mechanisms, and so we've created our own. And what it is a quick connect coupling, which enables us to have extreme amounts of rigidity, repeatability, but also to maintain the level of performance that is required in an industrial robot. On the right, you'll see a transmission. We have a patented transmission as well that we use, which has a very novel way of increasing the torque within our robot joint. So in robotics, the robot gearbox is actually the core of any automation or any robotic system. We need high precision, high repeatability, and we have this system that we have patented and we're continuing to develop right now. So from a collaboration point of view, from the UK and in Hong Kong, we have our company has extremely deep levels of technical knowledge and capability in all areas of engineering. So we develop our own motors, we develop our own drivers, we develop all our own embedded software for the controllers. We also do a high-level software, which is our graphical user interface, and we also develop almost all of our piece parts ourselves. So we have a very deep technical knowledge in a lot of different areas, and we also have spent a lot of time with, as I've mentioned, with our suppliers in China and also the whole of South Asia region, where we've worked very closely with them in order to optimize our system, in order to get the level of performance that we require, the level of fundamental cost, and also the level of control over our quality. And so it's really when developing a very sophisticated product like this, it's very important to be able to have very good fundamental controls over your core elements, which means that you have a deep understanding and you're able to optimize and get the best product, which is one of Innovo's greatest strengths. So Now I'd like to just briefly show another short video. So this video is explains really how the system can be used and why we have a different level of flexibility and automation compared to other robotic systems that you would see. So what you see here is teach and repeat, and we have a very simple to use teach and repeat system. But when the requirements change and the system requires a greater reach or a change in payload, our modular system is able to be flexible enough to be able to adapt to all different types of automation environments. So the user and the customers are no longer constrained to a certain size. They're not bound by a certain way of doing something. We have the most flexible tool in the market. So, so yeah, so the Innovo solution. What we have, flexible hardware. Our software is no code, so we use a very simple to use user interface, which I'll briefly show at the end, and it's extremely adaptive. So what that means is that what we do is we bring a tool like no other to the market. So our benefits we're very easy to use, completely flexible. We're a collaborative robot. So what that means is that they are safe to work around people. And this is very different to your industrial robot, where if there was a problem or a person operating near that robot and it would hit them, then the robot would never slow down. It would never detect that that person is there. And so our robot works as a collaborative tool to work around people. So it's safe to work around people. It's extremely flexible and extremely easy to use. And these are our main advantages. So how does modularity really affect or how does it compare to other systems? Well, if you take this case example I have on the screen now, where we have our robot, which is on the left, we have 3 different configurations that you see, which are labeled 10 kilos, 5 kilos, and 3 kilos. That is all one robot. So we change the link sections, we change the length in order to have that level of reach and payload trade-off that that would normally be seen in 3 robots. So what we say to our users or customers when they are worrying about exactly which system to use, or in the next project, which robot, what robot is going to be the most reusable once a certain batch production run is complete, we would say, well, give yourself the most flexibility because you don't know what project will come later or in 6 months time or a few months time. So you don't necessarily need to buy automation just for this project, but invest in automation because your automation is the future. So that's really how we try to position our product. So the title of this webinar is Smarter Automation. we have a lot of technology that we're bringing to the product that we already have in our product, but we're also bringing a step improvement to the platform as well. So we very much see our product as a platform product. We have lots of different interfaces. We can connect to our system in many different ways. We can use third-party tools, sensors, components. We have a very open architecture from a software and electrical point of view, and so we very much see our offering as something which can be used to automate today, but also to take our customers on an automation journey where you're able to add value later on and automate more and different things. So the one thing that we are developing in the background now is our connected system. So all our robots are can be connected remotely, so we can access given the right permissions, we can access any robot in the world with a 4G 5G connection, and that means that we can remotely log in to do maintenance, predictive maintenance, and also adaptive support for them as well, so we can see where there will be problems, and we take that data to be able to help improve the or optimize processes. So we very much see this as being a platform of the future. So our company, as I've said, we're 4 to 5 years old, 4.5 years old. We have many different applications within the pipeline of our business. We have because of our flexibility, our smart connections, we have lots of different industries that are asking us to help work with them to automate. So a few examples here where we have some applications. So on the left we have some vision systems, and we're working with a company in Sweden for a photogrammetry system. We already have our system within a restaurant right here in Hong Kong. We're also in the center. We're working on sample inspection and sample taking of COVID-19 samples, as well as a number of different other applications within education, within testing, within the food processing. Lots of different applications. And here is an interesting one that we're working with alongside Williams Advanced Engineering, and it's for battery testing for an EV vehicle. So one of the things that that you really don't want to get wrong is you don't want to put a bad cell into a battery pack of an EV, and so the most reliable way of doing that is to generate an automation system to do that. And so we have supported WE to do exactly that. And so we've speeded up a short video here where we're picking up battery cells, putting into a little tester, and then validating that it's okay with separate systems, but then placing them back in. So what we have is just a short example of where monotonous tasks, repetitive tasks can be easily automated, and this level of programming was done in under 20 minutes, and these battery builds could go on for 24 hours a day. So I'm just going to jump into another very short video. This is another application where we have an application within Hong Kong, so it's of interest, and this is a demonstration that we've carried out in an urban farm within Hong Kong. So this is one of the most advanced urban farms that I know of, and what they're doing is they are pushing the boundaries of urban farming, and we're supporting them with our robotic system, which is super flexible and can do many different tasks within there to help automate and optimize the food production. So what you see here is our robot system loading seedlings into an urban farm. So seedling salad seedlings, and on the right, what it does is it takes out those salads and harvests them after they've grown for 28 days, I believe. So this is an example where we have an extremely flexible system, and we're able to come in and fill the gap of the kind of manual labour and automation systems to increase efficiency and productivity. So here you see some of the outputs of the salads, and which I highly recommend. They're available in Pacific Coffee, in Coffee Academics, City Super. So they are very good organic salads, and I recommend them. So the advantage of robotics and automation is that you are able to operate 24 hours a day and keep the productivity going. And so this is where the advantages lie. And the company is called Farm 66. So I mentioned earlier how I was going to talk a little bit about talent of within our company, and within the UK and Hong Kong. It's something that actually I'm very proud of. The team that we've created here. We have exceptional talent, and you'll see very familiar names in these boxes here, where you have McLaren and ASM, which is much more familiar with in Hong Kong. We also have Cambridge. We have Williams, the Formula One, who are our backers, and so we have a very deep level of technical capability, and you really need it for such a complex system where you have to integrate very complex areas of engineering very tightly, from structural performance to control systems to high-end user interfaces to productionization. So there's lots of different facets within the robot arm, which makes the type of product very multidisciplinary. And the one thing that I've always experienced in robotics is that if you don't perform well in any of those areas, then it really shows, because a good robot system has to combine all those elements in a very good way. So that's our team. So again, just to briefly talk about our interfaces and how our solution fits together. We have industry standard compatible I/O. We have lots of different I/O for interfacing and communications to be able to command the system. So our system can be standalone, but it can be also embedded within an automation system. So we're very flexible in multiple different ways, which has really been our ethos from the start. So and that's, I've spoken for long enough now, so that's enough of me speaking. And now what what I'd like to do is give a brief demonstration of what I mean, of our robot system, and then we'll open the floor to questions. But I think the next thing is I'll do a small demonstration of a robot system behind me. Okay, just stop sharing and then stop that. Okay. So I hope everyone can see, at least see a little bit of what's going on. So what I have here is um, a part of the robot end. This is the carbon fiber element that I mentioned before. And what we have here is part of our module. So we have this as two joints within here, and we break down our joints to basically joints of pairs. So this is what we call our joint 5 and 6. Our joints 3 and 4 are here, and 1 and 2 are here. So what you see is they are separated with these black elements, which are our flexible link tubes or stiff link tubes, but varying lengths. So what I'm going to do really is just to show how everything goes together. We have here I've got just a small link tube section here because I've chosen to have a medium tube here, and I'll have a small link tube here. So I've already set that up. So all I'm going to do is take that link section, and all we need to do really is to put it on, put it into position, and then to move um, the, uh, the flexible coupling element. And so we have this locking collar arrangement where um, where which is one of our patented elements. And so what you have here is a um, a lock system. Now we've got a latch here, which means that it won't undo, which is obviously very important to be able to not have to have no worry about it coming loose. I'll just press the power button again. So what happens now is that the yellow light is flashing. So this is now picking out the configuration. It's very difficult to see here, and I must apologize on the display. But as you can see, or may be able to see here, is that the user interface will automatically update. So what that means is that our system knows what configuration it's in. So it's plug and play. We don't need to calibrate. It's all pre-calibrated. Everything is plug and play, like Lego blocks. And then what we would do is we would enable the system, and what you have, this system has now gone green, and now the system's ready to go. So the system is ready to go, and there's a few things that we do in order to make it really good and simple to use for our users. Um, so and then one of the ways is to really allow our users to um, operate it and use it in a really intuitive, flexible way. So the first way that we do that is we have what we call a zero gravity button. We'll press this button. Notice this has gone blue, and we can just move the arm around as if it's in zero gravity. So what we do is we move that to a position. We'd record certain positions, and and then in our flow diagram user interface, we would just record those steps. So it's as simple as move it here, record, move it here, record, and then we build on that program. We elaborate it however much is possible using logic, and and then very simply you're able to build up automation systems. A few other things that we do, we we have a room full of mechanical engineers, and mechanical engineers may know what a 3D space mouse is. So we actually configure our robot to a space mouse, so we can actually control it using the 6 degrees of freedom on a space mouse, um, which is um, which is quite intuitive for mechanical engineers. We found. But it does definitely take some practice. But we find that the um, the easiest way to be able to command the robot to do what you want to do is to press the button and move it around and really command it. But we're also always exploring different ways in which we can improve the usability, the user experience, in order to keep to our philosophy of smarter and easy automation. So what I've got now is I've got just a few waypoints which are already programmed. So we call them points, and we will just record a certain few points, and I will test it first of all. So I have 4 points here. That's point number 1. Point number 2, I will remove the robot here, which is pre-programmed. Then the third point that I've recorded is a little bit further away. And then the fourth one is here. So I've just quickly set these 3 positions, or 4 positions, sorry. And what I have is a repeat function here. So now I've tested those 4 points. I will press play on that. And then so now the robot system is running through that program in a forever loop, or until it gets an interrupt through any of our I/O. And so what we have is a way to flexibly automate very quickly in a safe way. So what I've done there is I've touched it. It's sensed that it's doing something a little bit that it shouldn't be doing. It's drawing a little bit too much current. So it's said, oh, I'm too close to a person, I'm too close to an object, and it will stop and it will be safe. Yeah, so that really concludes this short demo. I don't want to to take too much time, but I'm very happy to answer any questions that anyone may have.
Well, thank you very much, Jonathan, for the excellent and inspiring presentation. What I trust that there will be questions waiting for you to answer. And let me read the first one from Rob Law. He said, can you comment on the repeatability and reliability of this system when applied in a large-scale industrial automation environment?
Good question, Rob. Thank you very much. Yes, so we were very focused on repeatability specifically, because of repeatability is the most important part of the automation system as rather than accuracy. So we use very high precision encoders, and we have a tested repeatability of under 1/4 of a millimeter. So that's 0.125. We believe that we actually are much more repeatable than that in reality. And the real driver for repeatability is actually thermal expansion. Believe it or not, it's when you're getting to the levels of those levels of repeatability at the outstretched length, then the changes in the industrial environment will, and the warming up of the joints have one of the biggest contributing factors to repeatability. So and reliability, your second question. Well, we have worked very hard on focusing on how to make this patented coupling to be as reliable as possible. But we are an early stage company. You know, we have just launched our product into the market, so it would be unfair for us to claim or claim super high reliabilities. But we have tackled the reliability issues right from the get-go. We've built numbers of test rigs. We've go through cyclic testing day and night for many of hundreds of hours to try to build up our reliability figures and our performance standards. But one advantage that we actually do have is, or on the reliability front, is that if there are any problems with any of the joints, then you won't be having problems with the whole robot. You'll be breaking the robot down, we will be supporting joints by themselves. So actually, from a reliability point of view, as a system, we have fundamentally a higher reliability because of if you take into account what we would recommend is having some availability of additional joints on hand to be able to to support your operations. So so yes, thank you for your question. I hope that answers it.
Yes, Jonathan, there are more questions to come. Kem Kun Wong has asked, as the control system can be remotely accessed, how cybersecurity can be protected to prevent unauthorized use and hacking?
Good question. So we're working with a number of different companies to protect the access of our system. So this is not an area that specifically in my domain. You know, apologies from a mechanical background, but we are working with partners in order to ensure the protection is of the highest level.
Right, then I try to pronounce his name correctly. Ahmad Zakiri has asked, how much is the cost of your product? And do you have simulation software that one can work with your robots in virtual environment?
Okay, so our end user cost varies depending on geography, which um, is geography specific. So it's not something that I can go into right now. But please drop me a line and we can talk about the price. They are competitive compared to our competitors, so they will be more affordable. That I can assure you. And the second part of the question was, sorry. Oh yes,
Oh,
yes we do. Sorry, simulation. Yes, we do. So we do have also a cloud version of our software. So we're able to um, train on our software. We have a number of different instances where we have end customers and end users who are using and trialing our software, looking at the return on investment. They're looking at process times, the speed at which the robot can perform certain tasks, and also within our user interface, we have a different we have a number of inputs where we can bring in um, existing furniture that you'd have in your factory, or say a table or a CNC or a jig or a fixture. We can bring in step files into our virtual environment, um, and we can simulate and we can create the whole working environment within as what we call our digital twin, and we're able to offer that right away.
Great then. In fact, Mr. Zakiri has asked your contacts in the UK. I'm sure that you let him have the contact. We'll bridge you to in due course. Besides, Andrew Look says it's really great presentation about robotics development. Thank you. I would like to know more on how to ensure the system stability and how to do motion planning.
Okay, so motion planning actually is something that it's evolving all the time. So motion planning and our optimization, our path planning optimization is something we're constantly working on. We are because we're a modular system, we've had to do things slightly differently. We've had to have a what we call a inverse kinematics engine, which is the way we calculate the endpoints of the robot arm. We've had to calculate all those all the parameters in real time, and no other system has to do that because we could be in any configuration. So we work very hard on our motion planning, and it's something where we are continuing to improve as well as having our base product, which is already very good and optimized.
Right. Well, next question from Chi Kung Ngan. He says the arm the arm's profile is so stylish, and I believe that it is a good helper nowadays. I want to ask how long the technician needs to set up the whole process before starting the manufacturing work, if the work is quite difficult to end the process.
So it really depends. It depends on the process. So there are some processes which can be set up in a matter of minutes. So, for example, in the urban farm, we set up the environment in on the first time we did it. We did it in probably about 4 hours to set up the the uh, the application. But during development, we took the system away and we brought it back again. But we kept all our programs. All our programs are stored in the robot controller itself. And one thing that we're really proud of is that when we brought that system back in and we brought the robot, which had already proven and programmed was able to work, from the time in which we entered the door of the urban farm factory to the time in which we were starting to re-automate was around 17 minutes. So what we're really focused on is giving all of the tools to be able to be as flexible, be as easy to use, and to really try to make things as seamless and as easy as possible. So yes, I hope that answers somewhat of the question.
Right. Suji Liu has asked, can it be combined with other systems such as machine vision system for some complex control, or just can work individually? And how is the working load? Can it implement some cartooning or packing work in real manufacturing environment continuously?
So we have, as I've mentioned, we have lots of different I/O. We actually have a PLC within our system as well, with lots of different options and ability to input in lots of different ways. So we also have a connector right at the wrist, where at the moment this is not our gripper. This is a third-party gripper made by a company called Robotique. But we have a number of different drivers that are already prepared for lots of different I/O. So this at the moment is just a two-fingered gripper. So we have lots of different modules, and right on day one, we have a number, but we are constantly updating those drivers, and we're constantly getting more and more modules that are free to use for us in the coming weeks and months. And the second part of your question is, can it do cartoning and in a real manufacturing environment? Well, that's a good question. We are currently working on a customer who is doing some packaging within the toy industry. I can't say more than that. They're a live customer and we obviously need to protect their security and IP. So, but yes, we do. We're very able to do that.
The next question is from Serpent Mojabi, if I pronounce it correctly. He has asked, is the scale of the robots an area that you are currently working on and will eventually design larger and larger robots for working on larger industrial projects, such as building constructions?
Good question. Well, we've designed our system to fit within a very similar operating parameters as a person, actually. So where a person can lift probably 3 to 5 kilos at a certain reach, at a certain speed, we can generally outperform that. We can lift um, uh, 3 kilos at 1.3 meters, which is actually quite a large distance. And we've bound that kind of robot to suit our particular target applications that we have right now. But we also have a lot of different applications and a lot of different ideas and of scaling up the product and also scaling down the product to make it suit different markets environments. And we have a lot of pull from both those areas. But what we found is that we really have a very good sweet spot where we're able to expand quite a lot of the market as we have it, and we have hundreds of applications within that. So we would love to go into different markets and different avenues, including construction. Construction industry is a very interesting and good market for robotics because of the shortfall in labor, the aging population of the labor force within the building industry, and so that is a very interesting market. But we don't have any immediate plans, no.
Great. Mr. Wing Kwong Ringo Ng has this following question. Following up the application of your robot in large-scale operation, here it is. How does it comply to local codes like lifting appliance, load test, and periodic inspection?
Good question. So we are a collaborative robot, and so there are collaborative robot requirements that we have to meet in order to work safely around people and in a safe working environment. And we also have obviously it's a piece of lifting equipment to some extent, so we have to comply with certain lifting regulations to validate that we have a safe working load, and we are really focusing right now on the CE market environment. So it's really targeting the Western Europe and CE marking. So so that's how we deal with this.
Okay, nice. Well, in fact, Jonathan, I have a question.
Ah,
You have covered a lot about the features of your modular robotic arms. And my question is like this. You have components sourced from the mainland China, principally southern China, I presume, as you've said. And you have also supply chain in the European countries as well. Uh, Perhaps you covered it already, but can you elaborate how the division of labor between the mainland China suppliers and the European suppliers do?
The division of labor between the components that we source, do you mean?
Yeah, exactly.
So we evaluate our suppliers in the same way throughout the world, really, and obviously it's time, cost, and quality. So it's the three obvious things. Um, so we really we evaluate all our suppliers where we can. We will dual source a lot of parts. Um, so one example of this, there are certain PCBs that we have which are manufactured in Eastern Europe as well as being manufactured in Shenzhen.
Mm.
And there are other components where, unfortunately, we are single sourced because that's just the nature of the product we're developing. We have one supplier who we work very, very closely with on certain things in order to get our exacting requirements. So um, so over the years of developing, we've been developing the system for 4 to 5 years. There's a robot which is to my right and to the left of your screen, probably, and that's actually our third prototype. So we this unit now we have, which is our production version. It's the fourth iteration, and over that is those iterations of designs we have incrementally made improvements to the quality of the parts, but also carefully evaluated our suppliers. And so it really comes down to the suppliers that offer us the best of all those elements.
I see. Well, on the other hand, we have Ian Payne has asked, although the high upfront cost and with automation, do you think you can challenge China with day-to-day labor costs?
So it's very very interesting the dynamic in China as our the Hong Kong listeners would probably understand. The China labor rates are increasing at around 10% a year. So what happens, what we're actually seeing is that big factories are coming to us who would traditionally or 5 to 10 years ago would be churning out product and making good revenues and good profits. But these companies now are definitely feeling the pain with the emerging middle class of China. So if there's a perception that the that the China labor market is low and it will be low forever, that's not true. Actually, it's something which is rapidly changing, and what we see in Hong Kong and the South China part is a lot of factories are actually moving offshore, partly due to the trade war with the US, and partly due to labor rates. They're moving to other South Asian countries such as Vietnam and Thailand, and have been doing for a number of years. Um, so um, so there is actually a very large demand for automation within China to increase efficiencies and costs down. So actually, China is the biggest market for robotics currently at the moment, and forecast to be um, to be growing actually.
I see. So the next question is from Wing Hei Sang. Then that's me. Um, my question is like this. Uh, I believe that there are various key components you've sourced from the mainland China. Well, although my question doesn't specifically feature the China, I would argue that China or possibly other supply chains, you may come across issues of intellectual property. So in that sense, how would you do, or what have you done to protect your intellectual property whilst you outsource the manufacturing of components, especially the key ones from your suppliers in European countries and China?
So yes, very good question. So intellectual property is obviously very, very important to all companies who are developing products and tech. Um, and and I, the way we've approached it is that we have decided to separate our suppliers quite widely, but so consciously try to separate all our suppliers across a wide varying degrees of companies, and we've also separated some of our key components into constituent parts and manufactured them separately. So we have the way that we do it now. I would recommend to anyone else who's looking to manufacture a sensitive product is to also have a very carefully managed IP database of who uh, who has visibility of some of the designs and sensitive information, um, and in order to manage that very carefully. So we do that with a very high level of skill within our engineering team to build, assemble our products, and we do final assembly, certification testing, validation, calibration in house, and so we don't give any sensitive information to any third party, actually, irrespective of the supply being in China or Eastern Europe or the UK. So yes.
Mm. So I'm conscious of time, but allow me to ask the final questions, uh, which is like this. You've said that the carbon fiber components you've sourced it from southern China, and of course, certain components you've sourced it from Eastern Europe. Um, could you give me a nutshell? What types of components you have tended to find it more friendly to be sourced from China, and what other components more in Eastern European countries and well Europe overall speaking?
Um, so um, generally speaking, and I don't like to generalize too much, um, we would say that the uh, the more expensive to manufacture components, the castings, um, the time consuming CNCing, some of the fabrications, the carbon fiber, which are very quite labor intensive parts, we would source in South China and actually in Asia, um, and where there are um, uh, higher. I guess to some extent, some of the more of the electronics actually happens in Western Europe because of the proximity to some of the chips and some of the processors and some of the certain components. We actually have greater control over them in Western Europe. as a general statement.
Yeah, I think your answer is more than just a nutshell. And in fact, we are seriously running out of time, and I would ask your good self and all those who are participating to call out webinar to the end now. Nevertheless, I must say again, thank you very much for all your contributions um, with your highly thought-provoking and exciting sharing, Jonathan. And
Thank you.
I must say that my approach to you, in fact, started with reading a newspaper article in Hong Kong about your product back in last December, and I just wrote to you through your info mailbox, and you responded me. I would say your kindness to me by means of responding a stranger uh, has made our sharing today possible. And indeed, what you have shared with us candidly has really opened our eyes. We've learned a lot more about what robotics uh, can do and how the technologies have advanced uh, to the extent as it is now. So we've had an excellent time with you, Jonathan. So allow me to call on a round of applause, even though it's
A
just
virtual.
me alone here. I'm sure that my audience will follow suit as well. Besides, thank you for every one of your participation, fellow members, as well as your questions. I must say that the Q&A session has been very dynamic, and I have dealt with many questions, which is highly encouraging. So let's come to the end of the webinar. Once again, thank you very much, Jonathan, for your valuable contributions and insightful sharing today.
Thank you very much. Thank you for the invite and your kind words.
All right then. So fellow members, ladies and gentlemen, let's call the end of our webinar today. Thank you once again for your participation, and we'll see you next time. In the meantime, thank you and take care. Good health. Bye for now.
Thank you.